Hello and welcome to the Pocket Dojo podcast, the show where we talk about making the world a better place by making better things. I'm Paul Crick.
And I'm Marsha Singh. Today it's Paul's turn to lead the conversation, so let's dive in.
So one of the things we're doing on the podcast is we're looking at the idea of regenerative leadership. And what better way to do that than to tell some stories of people who are already embracing this and doing so successfully. So today's conversation is with the Managing Director of Qube Buildings here in the UK, Justin Murray, who's doing some fantastic work in the building sector, trying to disrupt it using regenerative principles and practices. So enjoy the conversation.
It's almost with what we're trying to develop is almost the lack of technology. There is no technology. We want to get rid of all the technology and just have something very, very passive and in its own right. And
I'm with you there.
Cloud. It doesn't need electricity. It
doesn't need AI.
No, it doesn't need any of these things. And it's actually really simple. And it's actually the simplicity is the technology, is the tech.
Yeah, no, it's great.
So,
okay, so thanks for being gracious enough to redo this. I hope the article lands a bit closer to home this time.
Yeah, I did have a quick flick through it. It seems
that's fine.
It's great. Yeah.
No, that's good.
A bit more on key.
Yeah, no, that's good.
Actually doing.
So we'll run it as last time. Real short and simple. I think the thing I mentioned last time, we were trying to do the Michael Parkinson thing, which is really to get to what lies behind the story as much as the story itself, because I mean it's a fantastic product and has loads of applications. But the thing I'm trying to get across to people with regenerative leadership is it's a mindset, and therefore, that's where it starts. Whatever you develop. Is driven by the mindset. And one of the reasons I love you and your example is it's very clear that's what shouts out loud and clear as to, well, this is what we're doing, this is why we're doing it, and this is where it came from.
Yeah. Well, I mean, it's like with any innovation or anything really, it always starts as an idea, and that idea is sown usually out of necessity or frustration or anger, or that there is a requirement for something. I think with lots of innovations, they come up with these great ideas and products and then try and find a problem for it.
Yeah.
Where as opposed to, what it's just conceived from the fact that we have a massive housing crisis, not just in the UK, but in Europe and globally, and no one really seems to be doing much about it. It's maybe a bit untrue. I'm sure there's lots of people trying to do something about it, but not from a genuinely sustainable position whereby we can make all these houses or homes genuinely sustainable. And it's like, God, I mean, how difficult can that be? I mean, there's an abundance of materials out there, natural materials out there, which are sustainable, and it's just about selecting which ones that fit together, that harmonize, and make a house, for instance. Sounds really simple, but
it does sound simple. But
through my journey, that's it. That I now understand why the reason that it is really difficult, because you have standards, you have European standards, you now have British standards, you have all these different sort of forces trying to sort of standardize a product to reach very high sort of building regulations. So I really started out on the journey because there's no way our children will ever be able to afford a house unless they have help from us. So it's like, we've got to do something. I've got to at least try to do something. And that's where it's really been conceived from, because it's just utter frustration and anger, and someone's got to do something about it. And I can't walk through the rest of my life thinking, we knew all these problems were about, and I didn't want to inconvenience my life because I'm going to have to change something and make a slight alteration to my to my sort of well-being because I have to be more sustainable. I'll let the problem, let the kids sort that problem out. This is our watch. We when I was at school, we were told that there are problems with the planet from an environmental perspective. And so we've been growing up with this potential massive problem. And it just seems to be growing. This problem seems to be growing and growing and growing. And it's lots of people are talking about it, but what are the solutions to solve the problem? And there seems to be such a lack of solutions. Even the government's like, well, they're almost, in order to deliver decarbonisation by 2050, there's going to be technology. It's like, well, we're drowning in technology now. We've got so much technology, we don't know what to do with it. And actually, this technology is not going to deliver the necessity to decarbonize by 2050. So that's where the journey really started through COVID. My other print business just fell off a cliff. So I was like, right, okay, what can I do? And so I decided, okay, well, I need to try and understand, how to make houses and homes better. So I went and studied from the Passive House Institution. And during lockdowns, I qualified as a passive house consultant. So then just gave me, another bit of sort of tools to be able to think, okay, well, look, this is the sort of principles behind the passive house innovation or how the Passive House Institute works and actually physically delivering a very low energy house, a very energy efficient house. So I sort of came up with this idea about modular homes and sort of punted it around to a few of my friends and sort of said, look, guys, I've got this idea, about making sort of industrialized house making, which is not new, that's not a new idea. And then I ended up getting introduced to my now business partner, Jaffa, who is a composite specialist. So it's a completely different sort of industry from sort of construction industry. I mean, the two industries just, very rarely meet. So it was sort of, they're coming of, sort of minds of, we have the same ethos, the same sort of principles, and he wanted to also make a change. And he had been working with a number of natural materials. And so between us, we've ended up developing a panel, which is now made from sort of flax or hemp and a bioresin and recycled materials like 100% post-consumer plastic. And the combination of those, so we've played around for a couple of years, trying to get all those really sustainable products to work sort of harmonize with each other to create a panel that would actually deliver a passive house that would also deliver the structure, structural integrity, air tightness, and all the other things that you need to build a house in a single panel. And that's where really that journey has come from.
Quite amazing. I love the story that goes with this. And it just shows the power of one or two or a small group of committed individuals to making such a significant difference. And as I was doing a little stalking of Qube Buildings website, it was interesting to see the number of applications that this technology you're building, the bioset panels, can be applied to. Is quite surprising how wide ranging it is in terms of the impact that you can have in freeing up carbon, the embodied carbon.
I mean,
buildings.
The whole point of the design of that, and I suppose this is part of the innovation, is actually it's just a panel. Okay, that's all it is. All we're making is we're pressing panels, so we can do it from an industrialized perspective. So part of its design is that we can press one of these panels in 15 minutes. And that's done manually. So if we could do it automatically with automation, we could probably get it down to about 6 or 7 minutes. And you can industrialize that very, very quickly, where you could be pressing hundreds of panels a day. And out of those panels, you can make glamping pods, houses, meeting pods, emergency shelter.
You were saying data centers, I thought was particularly interesting.
Data centers, because they need to be super energy efficient. So, I mean, the application for just a single standalone panel is enormous. And because it's being used from plastic or recycled plastic, was really important to us. And it does come with its challenges, like anything. I mean, a lot of people's like, oh, I don't want to use plastic. But actually using recycled material is very, very difficult, because we have an abundance of plastic, and we are now recycling lots of plastic, which is great, but we have very little use for the plastic that we are actually recycling. So they're just incinerating. I mean, it's crazy. I mean, I don't know, I think it's something like 70% of the recycled plastic that we have is just incinerated, because there's no use for that. So we have to find a way of using these materials. Now, from the build sector, using recycled materials is very, very difficult, because it's not consistent enough. It has to be consistent in order to deliver and maintain a constant quality within the panel, especially when you're building things like houses, which have got to last 70, 80, 90 years. And there's also things like fire as well, also have to be taken into consideration. So trying to reuse these materials and get the consistency out of them is incredibly difficult. So we've managed to do that, where we have got a good standard and a good quality control, and we are able to get certification for this panel, this biosec panel, so it can be used within the build sector, as well as other sectors, because they have to comply with the current standards. And that has been so difficult. I can't tell you how difficult that's been.
You were telling me last time we spoke, and it's probably worth sharing, and probably one of the most top of mind considerations is obviously compliance to fire standards. Obviously, with some of the disasters we've seen in history with buildings going up in smoke, and some of the tragedies that have happened. Talk a little bit about your journey through that, because it's quite a story, and I want people to hear how much attention you've paid to that, and almost the blood, sweat, and tears, and the cash that's gone into developing the panel so that it meets the fire standards criteria.
Yeah, I mean, with any innovation, you need to start at the hardest point where you need to get to, and then you need to work back. There's no point starting at the very easiest things and then slowly building that innovation to a point where suddenly, the laws of physics don't allow that panel to go or product to go any further, and yet you still have to further. So you always start with the hardest point. So I had to do for my son's school, I did like a careers talk, and I basically said, look, if you don't like failure, definitely don't get into innovation, because innovation is 90% failure. And I suppose part of when you have almost like a calling to something, that's your driving force, because you know that you can deliver something. You have this vision where specifically you know exactly what that looks like, and you just need to find ways in order to be able to get to that vision. I mean, it's like Edison. He knew that if you put electricity through a material, that it would get hot and illuminate, but not burn. And he tried thousands of materials, but he knew the vision. He knew that would work. It's just a question of finding the right material. And because he knew it would work, that was his driving force. And you know, there's the same for me, and same for Jaffa as well. So we know the vision, we can get there. It's just, you know, the various steps to get there. And fire is the hardest part in the build sector. So, you know, we had to design the product that has to sort of reach the current building standards.
And it's plastic with an internal fiber
Yeah, well,
based thing. So you would imagine, to the uninitiated, well, that sounds like it's quite susceptible to fire. So
yes.
yes. So how have you overcome that? Because that's quite a feat.
It is a feat. I mean, you know, it's a journey like all these things, and a lot of it has been failure. And we tried various other technologies to try. So basically, in a nutshell, the standard that which we need to deliver is a standard called EN 1365-1, and that test is basically put into a furnace. So your design, our panel has to go into a furnace that's 3 meters high, 3 meters wide.
Mm-hmm.
It's like a cube with one face open, and you have to build your wall inside that furnace, and then the temperature then simulates a sort of real world fire. So the temperature goes from standing room temperature at 20 degrees up to about 825 degrees in about 7 minutes.
Wow.
And plastic melts at about 250 centigrade. So steel will melt at about 1300 centigrade. Aluminium will melt at about 650. So, and obviously natural fibers, you know, they're pretty flammable. So yeah, trying to find a methodology that would be able to reduce the heat from the face, the attack side, to the point where it gets into the insulation, the plastic. We had to reduce that temperature down by 600 degrees in the space of about 45 millimeters.
Wow.
So on top of the furnace at 825 centigrade, it has to last half an hour with a 1 ton load, and it mustn't lose any structural integrity. And so we managed to get 58 minutes or 57 minutes out of that test. And in fact, unfortunately, I had to stop the test because of impending danger to the equipment. But the milestone for us would have been 60 minutes, but a pass is 30 minutes.
Mm-hmm.
So that was a momentous when we actually did finally do it. But we did too many tests that actually lots of it failed, and it was like back to the drawing board again. It's like, okay, well, that didn't work. Okay, so let's use the data and the information about how that all went, and try and keep finding another methodology to be able to deliver that, and we did it.
So tell me a little bit about your supply chain and how things sort of come together, because obviously you've got to source the plastic, you've got to source your fibers, and then put it through a series of processes to have the raw ingredients then to construct this panel. Tell us a little bit about that.
Yeah, I mean, the supply chain is a problem because the whole sustainable materials is still really at its infancy. The consistency of the materials is difficult. The supply chain is difficult. Things like, the hemp and the flax. Well, there are big problems with growing hemp. Certainly in the UK, it needs licensing. Hemp is an incredible plant. It sequesters about 160% of its own weight in CO2. It grows in about 10 weeks. So unlike wood, where it takes 25 years before you can sort of harvest the wood and use that as a building material, hemp can be done in 10 weeks. In fact, you can get two harvests a year out of it, and in some climates you can get almost 3 crops a year out of it. So it's a very, very quick crop, but getting that consistency out of the material is very, very difficult, because the machinery, there's only a handful of machines in the world that can sort of process that hemp to to get it into a composition that we can use it, but also is consistent enough for us to ensure that we hit compliance, to make sure that the product that we produce is consistent and compliant to the building regulations. So in part the reason why there's not lots of sustainable products out there, because you have actually the supply chain is still not mature enough to deliver a constant. I mean, it is getting better, and we will get there. I suppose what needs to happen is that you'll need some business, big blue chip companies say, right, we're going to build, I don't know, 10,000 homes or buildings out of your bioset, and then we can sort the supply chain out.
I think it's interesting, isn't it? Because I think you were saying that 80% of land is suitable for growing hemp in the UK, and the only barrier seems to be the THC composition within it, which is the hallucinogenic components. Now, are there strains of hemp that have lesser amounts of THC and that are suitable? Or
I mean, hemp is different to marijuana. I mean, all
yes.
Same sort of family or same specimen. I'm not a horticulturist, so I'm not.
No.
In fact, actually, I'm going up to see a flax farm and a hemp farm at the next week. So I'll on a bit more next week. So they are in hemp. There's not a huge amount of THC in it to have an effect, which is why you need a license. But why you need a license to grow hemp, it just seems odd, because there's no way you can smoke it.
No. Well, that was my impression, but again, I don't know enough. So what's the future direction? What's the ambition, sort of in the next 6 to 12 months, Justin?
Well, we're still trying to sort. I mean, our PET, which is our recycled plastic bottles, that supply chain is very good. It's a great manufacturing plant in Belgium that can supply a consistently good product. The hemp and flax. The flax is fairly good now, but it's mostly done in France, so we have a transportation problem. And every time a consignment from France, it's like £550 each consignment. So even if we just bought one roll, so of course that increases our costs. So our cost base is still huge for our product, because the supply chain is not sorted out really, where we can get the goods and materials in by the truckload to reduce the transportation costs, because we're still working pretty much small numbers. But we're hoping that we will be able to get some sort of contract whereby we can supply a consistently number of panels, and then we can sort our supply chain, and hopefully our price point will then start coming down, which would make the buildings much more affordable and almost more cost effective than sort of traditional builds. But at the moment we're a lot more expensive, purely because the supply chain and our manufacturing facility is still not so automated. It's all done by hand still, and once we've got the machines in to be able to do that properly, then our price point is going to come right down.
Yeah, I think what you illustrate beautifully is the fact that whilst you can come up with a point solution, it's a systemic collaboration that's required to actually make that happen, and that's part of the shift in mindset that we need from all potential players to support the process.
I mean, that will happen. I mean, if you're a businessman, or you're a pension fund or an investor, and you think, okay, well, look, in 26 years' time, that we are supposed to be completely decarbonized, and the build sector is still using, I think it's something like 39% of carbon, or contributes 29. Sorry, contributes to 39% of our carbon. It's just ridiculous. You would have thought it would have been easy. That's the low hanging fruit, isn't it? Well, okay, it takes 5% out of the build sector would be easy. And if you compare that to, let's say, the whole aviation sector, that's just 3%.
Wow.
So, I mean, taking sort of 5-10% out of the build sector should be relatively simple. So in 26 years' time, we need to be carbon neutral, and that's just an absolute pipe dream.
Right.
I'm fairly confident. I'll bet you pretty good money that in the next 15 years, you will see massive government shifts, changing legislation to ensure sustainability, because they will. And there's already lots of lawsuits against varying governments because they are not complying to the Paris Agreement. Now there's a precedent that the governments, if they're not complying, will do the proper greenwashing because they're not complying to the Paris Agreement. It's enough to be in favour of the claimant. So I think that's going to happen a lot more.
I think that makes a mouth-watering prospect for COP29. That's people are starting to talk about, and it'll be interesting to see if stories like yours get told in those places.
Well, it's going to happen. I mean, you don't need to be a betting person to think, well, in the next 15 years, and the thing is with any business or any product, you're not developing the product for today's market. You're developing the product for 10 years' time, or your business model in 10 years' time, because by then you'd have sorted all the bumps out, you'd have got your supply chain sorted. And then, when there's this massive explosion of the necessity of your product or your services, whatever innovation that might be, that's good marketing, that's good strategy, that's identifying what is going to be the problem in the next 10 years. And one of the things I love about our products is that actually building homes and shelter, that's never going to change. In 100 years, we are still going to need homes. We're still going to need shelter. This is something that any business person should be really thinking about. What's not going to change?
Yeah, interesting. Justin, where can people find out more about you and the work you're doing and the biosip panels?
Well, our website is www.bio-sip.co.uk.
So SIP is SIP, yeah?
SIP, yes.
Yes.
Yeah, biosip.co.uk, and you'll be able to get all the information off that website.
Justin, this is, for me, this is an inspiring conversation, because you're walking your talk. You're an example of the shift in mindset that we need to get beyond sustainability, which is do no harm, to actually going back and saying, how do we regenerate? How do we rebuild our biodiversity and do that? And the things you talk about here are great examples of ways that can be done. And I only wish power to your elbow to support that. Thank you so much for being a guest on the Pocket Dojo, and I look forward to seeing what happens next and where you go next. I wish you every success.
Thank you very much, Paul. Thank you.